Find the derivative of y equals 1 minus x squared y, a, by implicit differentiation, b, by solving for y explicitly and differentiating the result. Show that the results are the same. For part A, we're going to find the derivative by implicit differentiation. We have an implicit equation. It's not solved for y in terms of x, but it does have y and x related to each other through the equation. We can take the derivative of both sides with respect to x, indicated by the prime on both sides. The derivative of the left, the derivative of y, is a 1, but because it's a y term, we always have a y prime happen. We take the derivative of a y term. Equals, the derivative of 1 is a 0, and then the negative x squared times y is a product rule. The derivative of the first, derivative of negative x squared, is negative 2x times the second left alone, plus the first left alone, which is a negative x squared, times the derivative of the second, which is a 1, but because it's a y term, we get a y prime every time we take the derivative of a y term. So we have y prime equals negative 2xy minus x squared y prime. We want to isolate the y prime terms to one side. We have two terms that have a y prime. We will want to add this over to the left side. So we have y prime plus x squared y prime equals to negative 2xy. We can now factor a y prime out from the left side, and that will leave us with a 1 plus x squared equals to the negative 2xy. And we can solve for y prime by dividing both sides by the 1 plus x squared. And there's our derivative y prime. For part B, we want to solve for y explicitly. This isn't always possible, but if it is possible, it's an optional way to find the derivative. We want to isolate the y terms here by bringing them all on one side. Let's move this to the other side by adding it over. We have y plus x squared y equals to the 1. We can now factor the y out. And that'll leave us 1 plus x squared equals to 1. And now divide by the 1 plus x squared. And we now have solved for y in terms of x. This is called an explicit function, where y is solved explicitly in terms of the x. Before we take the derivative, let's rewrite this expression, since the numerator is a constant, as 1 plus x squared to the negative first power. Because we do not need the quotient rule, we just need to use the power rule to find the derivative. So the derivative of y prime here will be bring down the power, leave the inside alone, subtract 1 from the power, and then multiply by the derivative of the inside to complete the chain rule. The negative in the 2x will stay in the numerator. The negative can even move out front. But the 1 plus x squared to the negative 2 will move to the denominator to become a positive exponent. And there's our explicit derivative, y prime. We want to show these results are the same. So we want to show that this y prime will match the other. They're almost the same looking right now. They both have a negative, they both have a 2x. But the denominator here is squared, and here it's to the first power. And that's because y involves one of them in the denominator to the first power. It's 1 over 1 plus x squared. What we can do with our derivative we just found, if we want to make it look like the other one, is separate the 1 plus x squareds apart from each other so that we have just the first power in the denominator, and we have a separate fraction Now the numerator, we have a minus 2x, so we'll have a 1 in this numerator. These fractions will multiply each other back to what we had just resulted in for y prime. But by separating them, this can be replaced with a y. And so this can now be written as negative of 2xy over 1 plus x squared when this gets replaced with a y. And that matches exactly the result that we have in part A.